Hi girls. So the percentage yield went quite well. So the next one, which is example 10, is to go back through water of crystallization. So this calculation comes up as question 1, always causes issues for everyone. So we'll take a look at a couple more of these ones for you. So the one in the example that we've got, so again, I'm on this sheet here and I'm down at example 10. Okay, so we're looking at Epsom salts and they have a formula of MgSO4. And you have your XH2O. So you're going to know it's a water of crystallization because you've got this. We again remind ourselves what this .XH2O means. It means it's a hydrated form of that particular compound. So this compound is not pure, it's hydrated, so they'll form large crystals. And what we're trying to find out is for every one of these magnesium sulfates, how many waters surround it to help you build this crystal. Okay. We're told we have 24.6 grams of this stuff that was weighed out. The Epsom salts were heated to remove the water of crystallization, and there were 12 grams of magnesium sulfate were formed after heating the crystals until there was no change in mass. Calculate the value of X. So this was not actually asking you for a percentage of water of crystallization, but I'm going to take a look at doing that part of it as well. Okay, so your first thing is to take a look at what happens. So your magnesium sulfate was heated, so it went from having the water attached to it to the water disappearing off as a gas in this situation. Okay, so we've 24.6 of the hydrated one and we've 12 grams of this as we stand. So the first job we're going to take a look at is see if we can work out the moles for each of these ones as we go across the line. So 1 mole of magnesium sulfate, you go to the periodic table and it's 120 grams. If I had 12 grams of it, then I'm 1 divided by 120 and multiplied by 12. So I have 0.1 moles of magnesium sulfate. Okay. The next thing to say is, well, if I had 24.6 of it to begin with and now 12 after I heated it, the difference between these two numbers, so 24.6 minus the 12 grams, must be the amount of grams of water that I had. So I had 12.6 grams of water. Okay, and we're going to do and convert the moles here for water. So for the water now, 1 mole of water is equal to 18 grams from the periodic table again. And I didn't have 18 grams, I have 12.6. It's 1 divided by 18 multiplied by 12.6, and that's 0.7 moles of water. Okay. I said I'd do the percentage, so if I was to take a look at the percentage is how much water I have, which is 12.6 grams divided by 24.6 grams multiplied by 100 over 1. So I was asked for the percentage of water. I can do percentages using grams. Okay, so it's 12.6 divided by 24.6, and that's 51.2%. Now, why can I do percentages with grams but I can't do ratios? Well, when you're comparing two things, you have to have it in moles. If I'm just working out how much water I have in something, I'm not comparing it to anything. I'm just working out the amount of water, so therefore I can do that in grams. If we take a look now at our ratio, our magnesium sulfate ratio is to our water ratio. That has to be given to us in moles. So we've got worked out that we've 0.1 mole and 0.7 moles. That's our ratio. So we don't normally see ratios looking like this. It's normally 6:1, 7:1, 10:1. So to get it to look like we'd like it to look, we'll divide across by the smallest number. And the smallest number in this case is 0.1. So that is a 1:7 ratio, and therefore X is equal to 7. Okay. So to take a look at a couple of further water of crystallization ones, I'll ask you to take a look in your textbook at page number 192, and it's 13.15 and 13.16. And I'll give you another couple of experiences at those particular ones. Okay, so that's the water of crystallization, girls, and best of luck with it.